Hello, my name is Jinchuan Yang. I'm from Waters Corporation. Today, I'm going to talk about the enhancing analysis of B group vitamins using Acute Premier solutions. I'll start with the challenges in LC analysis, basically why we developed this new technology and what technology behind this. And also, we will talk about a little bit about the challenges in the B vitamins analysis. And then we will spend most time to show you what kind of benefit that this new technology can bring you in the B vitamins analysis before we conclude. So molecules tend to adhere to any exposed surface. The driving force for this can be electrostatic force, hydrogen bonding, or hydrophobic interactions, or other forces. So usually this kind of adsorption is not a big deal in the LC analysis and not causing any significant problems. But there's one particular adsorption, someone called it metal ion mediated adsorption. It can cause a big headache in LC analysis. This adsorption often occurs to phosphorylated compounds such as protein, peptides, etc. And the driving force for this kind of adsorption can be ionic interactions or similar to the formation of the coordination complex or chelation. Actually, this kind of interactions between metal and analyte is used in the IMAC, immobilized metal ion affinity chromatography, for the purification and separation of proteins or peptides. So the detrimental effect of this adsorption can be poor peak shape, peak tailing, and diminished recovery of compounds, and often result in limited sensitivity and poor reproducibility in LC analysis. There are several solutions that people can choose to address the adsorption issue in LC. One is to add the additives to mobile phase or samples. For example, people often use the TFA in the mobile phase to reduce the adsorption problem. Also, people can alter the mobile phase, like increase the ionic strength or change the pH to try to eliminate or reduce the adsorption. The limitation to this approach is that adding the additives can bring in additional issues, such as ion suppression for the mass spec detection. Also, the additives sometimes work for a group of compounds but not work for other group of compounds. So it's an analyte specific solution. It's not a generic solution. Another approach is to use the alternative hardware materials. People use PEK or PEK-linked columns try to eliminate the adsorption. And also people use titanium alloys instead of the stainless steel to try to solve the issue. The limitation to the PEK material is that it has a limited strength and is not compatible with some organic solvents. The use of titanium alloys sometimes do help to reduce the interaction between analyte and the ion surface, but it's still a metal. It can have interaction between the titanium alloys and analyte. So it's not completely solve the problem. The third approach, people can use the passivation or conditioning. So the passivation using acid can remove the metal ions on the surface, but it's often time consuming and could damage to the system column. And conditioning with the high concentration of samples or standards sometimes do help to reduce the absorption, but it's a temporary fix and need to be repeated frequently to maintain the effectiveness. So there's a need for a more universal or permanent solution to this issue. That's why at Waters we developed technology. It's called max peak high performance surfaces. So basically, it put a layer on top of the metal surface. It's an inorganic organic material or layer, so it can block the metal surface and prevent the interaction between the metal and the analyte, such prevent the reduce the absorption or eliminate the absorption. This material, the hybrid surface material, is actually has the chemical composition similar to the base materials used in the BEH column. It has the ethylene-bridged siloxane materials, and it has it's more hydrophilic than the PEK material, so it's less prone to the hydrophobic absorption. So we have the Acute Premier solution, which includes the LC and the column and the fluidic path or the wettable surface in the LC system, and also in the column is processed with this max peak HPS technology. So all the wettable surface in the system and in the column has this coating, or not coating, has the hybrid surface that prevents the interaction between the metal and the analyte. So additional background about the B vitamins. So B vitamins are essential micronutrients for normal human metabolic and physiological functions. It cannot be made by humans itself in sufficient amount, so people need to have abundant supply of these micronutrients in diet for the normal growth and health of human body. And nowadays, the B vitamins are often enriched or fortified in food. For example, in infant formula and some beverage and the cereals, they're often fortified with vitamins. And the determination of B vitamins in food is commonly required in the food manufacturing process to ensure a consistent quality of the packaged food, and also to comply with the food labeling requirement. And also, the regulatory bodies also need to assess the B vitamins in food for research or for the regulation purpose. So we investigated the potential benefit of using Acute Premier solutions for the B vitamins. We focus mainly on the peak intensity, peak shape, carryover issue, and sensitivity. We also evaluated using the real samples. Here are the structures of B vitamins included in our study. As you can see, this is the group of compounds of a very wide and diverse structure. The molecular weight range from less than 100 to over 1,000, and this group of compounds contain different functional groups, including phosphate functional group, carboxylic acid functional group, as well as amine, amide, etc. The analysis of B vitamins is not easy. There's a number of challenges in the analysis of B vitamins. And first of all, the B vitamin is not very stable. It's very sensitive to light, to the pH, and also the other vitamins or metals can also affect its stability. And the different pH conditions, some of them can degrade very fast. Its solubility is also kind of interesting. Even though this group of compounds is called water-soluble vitamins, but for some of them, they have very limited solubility. For example, the biotin have a 0.22 milligram per ml, and for the folic acid, it has the 0.0016 milligram per ml solubility in neutral water. And these B vitamins have a lot of vitamins. Some of them have more than 100 vitamins exist in the natural product. So it's kind of very challenging to analyze and extract these vitamins from the sample. And it exists in a wide range of concentration level, from micrograms to milligrams per serving. And some of the internal standard is very expensive to obtain. There are many industrial standard methods available for the B vitamins analysis. This slide lists a short list of a number of AOAC International official methods. And you can see that these B vitamins usually analyzed as a group, as individual B vitamins. So it's not analyzed simultaneously for all the B vitamins. And the number of water products being used in the method development for these methods. Here are the experimental conditions. In our comparison study, we use two LC systems. One is Acute H-class plus. This is part of the conventional setup. Another one is Acute Premier system. This one has the identical design of this H-class plus, but it has the max peak surface in it. We also use two columns. The water is Acute UPLC-BH C18 column and Acute Premier BH C18 columns. These two columns are identical to each other, except the Premier column has the max peak technology. The mobile phases, we have 20 millimolar ammonium formate in water at pH 5.0 as mobile phase A, and methanol as mobile phase B. And column temperature is at 40 degrees C. And we have the gradient programs list here. We use the one mass spec instrument. It's a Zivo T2S micro mass spec instrument with these two different setups. This shows the MRM transitions for the B vitamins analysis. The transition in bold is for the quantification purpose. As I mentioned earlier, in our investigation, we mainly do the comparison studies. We use two LC setups. One is called SOP, another called HPS. The SOP representing the LC system and column from the conventional setup use the stainless steel surface. It does not have the max peak HPS technology. The HPS setup contains LC and also the column that come with the max peak HPS technology. The two LC systems are identical to each other, except the Premier system has a max peak HPS technology. Also, the columns we used in order to eliminate the batch-to-batch variation in the packing materials. The column we used are from the same batch packing materials, so there's no difference in the column performance. And in our study, we do the side-by-side comparison because the absorption process is a very dynamic process. So we carefully do this side-by-side comparison study. We use the same samples, the same sample queue, And also, we only compare the results from the corresponding injections in a sample queue. So we want to keep everything the same when we do the comparison study. And here's some results we obtained in our comparison study. This one shows the peak area comparison obtained from SOP setup versus HPS setup for the first 7 initial injections. Again, SOP representing the system, the typical conventional system without the max peak HPS surface, and the HPS setup representing the system with the new max peak HPS technology. The blue bar representing the data from the SOP setup, and the orange bar representing the data from the HPS setup. And you can see that the peak areas generated from the HPS setup is always either equal or higher than the peak areas from SOP. So higher peak areas is obtained with HPS. Also, if you look at some of the B vitamins, the FMN, flavin mononucleotide, the thiamine, the TPP, the thiamine pyrophosphate, and the PLP, the pyridoxal 5' phosphate. They have a significant higher peak areas from the HPS setup than the SOP setup. This slide shows the peak-tilting factors calculated from those 7 initial injections. Again, the blue bar representing the data from the SOP and orange bar representing data from the HPS. You can see that most of the B vitamins they have comparable peak-tiltings except the thiamine, which has a significant higher peak-tilting factor from SOP than the HPS. Also, since the TPP there's no peak observed with the SOP setup, so there's no peak-tilting calculated for the TPP with the SOP setup. And this slide shows the comparison in the initial injections as well as after extensive use of the system. The columns, the chromatogram on the top is the result from the initial injections. The green trace representing the data from the HPS setup, and the red trace representing the data from the SOP setup. And as you can see here, a huge difference between the green trace and the red trace indicate that a significant higher peak areas or peak intensities obtained with HPS setup during the initial injections period. And then after extensive use, what I mean here is that after at least 50 injections of samples and standards, and the system already be exposed to the analyte, and some of the active site on the surface already been saturated with analyte, so it's less and less absorption occurring in the following injections. So in this period, the difference between the green trace and the red trace is becoming smaller. But still, you can see that there's a small difference between the green and the red traces. That indicates that even after extensive use and after repeated injections, the SOP setup still cannot deliver the same kind of performance as HPS setup. And also for the thiamine compound, you can see that after the extensive use, still there's a large difference between the HPS setup and the SOP setup. And also peak shape is not improved over the use of the system. So let's talk about sensitivity. Here's the comparison of the chromatogram from standard solutions at different concentrations range from 3 ppb to 10 ppm. The compound is FMN, flavonomononucleotide. The chromatogram on the right is from the HPS setup, and the chromatogram on the left is from the SOP setup. And by the visual inspection, clearly you can easily see that the detection levels for the HPS setup is much lower than the detection levels for the SOP. So a more sensitive detection can be obtained with the HPS setup than the SOP setup. Here's more data about sensitivity and also the calibration. Here is a table listed the LQ, the range of calibration, and also the R-square for the fittings for the HPS and SOP setup for a number of B vitamins. As you can see that for some of the B vitamins, comparable results in terms of LQ is obtained, but for others, specifically the riboflavin, the thiamine, the nicotinamide, the FMN, PLP, and the 5-MTHF, 3 to 10 times more sensitive detection can be obtained from HPS than SOP. And here's some data for the carryover investigation. So carryover is a common issue for the B vitamins analysis. And here we compared the results. The chromatogram on the top, the row C, it shows the chromatogram from the injection of a very high concentration standard at 10 ppm level. The chromatogram, all the chromatograms shown here are normalized to the same scale. So row B, which is the middle row, is the blank injection chromatogram with the SOP setup right after the injection of the high concentration standard. You can see that in the blank injection, there are some residual peaks left over from the previous injection. This is carryover. And the level carryover is range from 0.03% to 0.1%, which is not very high, but still evident. It's still discernible. The chromatogram at the bottom is from the HPS setup, and you can see there's nothing, no peak appear in these blank injections. So this means that with the HPS setup or the max peak HPS technology has less prone to the carryover issue. And here's some chromatogram obtained for the standard using the Acuity Premier solution. And next is some chromatogram obtained for the energy drinks and dietary supplements. And here's some additional results for the energy drinks. We have 5 vitamin Bs in these energy drinks, the 3 energy drink samples. And for energy drink number one, we'll also do a spiking experiment to assess the accuracy or recovery of this analysis. And hopefully you can see that for the energy drink number one, we have spiked the cyanocobalamin, the riboflavin, pantothenic acid, pyridoxine, and nicotinamide. And the recovery is ranged from 91% to 107%, which is very, very good, very accurate. And also you can see the RSD level in the determination of these B vitamins. The number range is usually below 7%. And for the cyanocobalamin, because of the low concentration, the RSD level is a little bit higher, 17%, which is very common at this level. And here's some results for the dietary supplements. So we evaluate the determination of B vitamins with the actual B complex dietary supplements. And also you can see the RSD and the recovery. For this group of simultaneous determination of this group of B vitamins, we have the recovery range from about 80% to 120%, which is pretty good for this simultaneous analysis of this group of compounds. And the RSD range less than approximately 7% is obtained, so which is pretty good. So here's a summary of this investigation. So by using the Acute Premier solution, which has the max peak HPS technology, we obtain increased peak area or peak intensity, better peak shape, and improved detection sensitivity. And also we observed that the benefit is very significant during the initial injections of the initial use of the system. But even after extensive use, we still see a difference between the SOP and HPS setup. That means that even after extensive conditioning of the existing instrument, the stainless steel-based instrument, you probably can reduce the problem, but still may not achieve the same level of performance as the HPS technology can bring you. And also we noted there's no carryover observed with the Acute Premier solution. So it indicates that more reliable results can be obtained with Acute Premier solution. And also during the investigation, we found that significant improvement also observed for non-phosphate containing compounds. So for example, the thiamine, riboflavin, nicotinamide, and the 5-MTHF, this compound is not phosphate containing compound. This means that maybe there's the absorption, the metal ion mediated absorption is occurring to a wider range of compounds. And this solution could benefit a lot of other analyses in food testing. And the LC-MS analysis of B vitamins using the Acute Premier solutions have been evaluated with energy drinks and dietary supplements, and excellent accuracy and repeatability is obtained. So there's additional information can be obtained at our website, at the waters.com website. So here lists a few additional relevant application notes that we generated. If you're interested, you can go to our website to download this information. And thank you again for your time.